The Sukhoi Su-57 Felon represents Russia's vision of modern air combat, an aircraft designed not only to fight in the skies but to survive and dominate in an era where detection often means destruction. Developed as Russia's first fifth-generation fighter, the Su-57 was built to counter advanced Western aircraft while maintaining the traditional Russian emphasis on speed, agility, and raw kinetic performance. Rather than copying Western stealth philosophy outright, the Su-57 follows a hybrid approach, blending reduced observability with extreme maneuverability, powerful sensors, and long-range weapons. From the moment the Su-57 enters the airspace, it presents a different character compared to other stealth fighters. Its design prioritizes aerodynamic performance, allowing it to operate at high speeds and altitudes while retaining the ability to perform dramatic post-stall maneuvers. The wide blended fuselage, angular wings, and carefully shaped inlets work together to reduce radar signature, especially from frontal aspects. While it may not be as stealth-optimized as some Western counterparts, the Su-57 compensates by being exceptionally fast, highly agile, and heavily armed. One of the defining traits of the Su-57 is its thrust vectoring engines. These engines allow the aircraft to change direction rapidly, enabling sharp turns, rapid climbs, and extreme maneuvers that can overwhelm opponents in close-range combat. In visual range engagements, this agility can be decisive, allowing the Su-57 to point its nose toward targets at angles that would be impossible for conventional fighters. Russian doctrine still values dogfighting as a viable combat scenario, and the Su-57 reflects that philosophy clearly. Beyond maneuverability, the Su-57 is built around a multi-layered sensor system. Its primary radar is supported by additional side-mounted arrays, allowing the aircraft to track multiple targets across a wide field of view. Infrared search and track systems enable passive detection, allowing the pilot to locate enemy aircraft without emitting radar signals. This passive capability is particularly valuable against stealth aircraft, whose low radar visibility does not make them invisible to heat-based sensors. The cockpit of the Su-57 reflects a blend of modern and traditional design. Large digital displays provide flight data, sensor fusion, and weapon information, while retaining physical controls for critical systems. The pilot is supported by advanced automation, but Russian design philosophy emphasizes keeping the human operator deeply involved in decision-making. The aircraft is intended to fight in complex environments where electronic warfare, deception, and rapid tactical changes are constant. Weaponry is another area where the Su-57 asserts its identity. Internal weapon bays allow it to carry air-to-air and air-to-ground munitions while preserving stealth characteristics. Long-range air-to-air missiles give the aircraft the ability to engage opponents well beyond visual range, while short-range missiles combined with helmet-mounted targeting systems enhance its close combat lethality. The Su-57 is also capable of precision strike missions, carrying guided munitions designed to hit high-value ground targets with accuracy. Electronic warfare plays a central role in the Su-57's combat doctrine. Rather than relying solely on stealth to avoid detection, the aircraft is designed to disrupt enemy sensors and communications actively. Its electronic countermeasures can jam radars, confuse tracking systems, and create false targets. This approach reflects Russia's broader emphasis on electronic warfare as a key element of modern conflict, where controlling the electromagnetic spectrum can be as important as controlling the airspace itself. Operationally, the Su-57 is intended to function as part of a networked force rather than as a lone hunter. It can share targeting data with other aircraft, ground systems, and unmanned platforms. In future combat scenarios, the Su-57 is expected to coordinate with combat drones, extending its reach and reducing risk to the pilot. This manned-unmanned teaming concept reflects a shift toward distributed air combat, where information flows between platforms faster than the enemy can react. Despite its advanced design, the Su-57's development has faced challenges. Production numbers have remained limited, and the aircraft continues to undergo upgrades and refinements. Engine development, avionics integration, and stealth optimization are areas of ongoing improvement. However, these challenges do not diminish the aircraft's significance. Instead, they highlight the complexity of building a fifth-generation fighter capable of surviving against the most advanced air defense systems in the world. In modern combat, the Su-57's strengths lie in flexibility. It is capable of high-speed interception, close-range combat, long-range missile engagements, and precision strike missions. This versatility allows it to adapt to different operational needs, whether defending airspace, escorting strike aircraft, or conducting offensive operations. Its ability to operate in contested environments, supported by electronic warfare and sensor fusion, makes it a dangerous opponent even for advanced stealth fighters. The Su-57 also represents a strategic message. It signals Russia's intent to remain a major air power, capable of developing indigenous solutions to modern military challenges. While debates continue about how it compares directly to Western fifth-generation fighters, the reality of air combat is that no aircraft fights alone. Doctrine, support system.